So as we discussed in the last video, energy and matter go hand in hand. Energy may not be exactly what you think of it as, though. Energy is defined as the ability to do work, where work is like moving something, not just thinking in your brain. Okay, so kinetic energy is the energy of motion. So this is where things are actually moving, kind of like what we talked about last time. Potential energy, on the other hand, is like stored energy. Now, this could be due to position of an object, like you're at the top of a roller coaster, or it can be stored energy in chemical bonds, like gas and wood and that type of thing can store energy. Heat is something we consider to be a result of kinetic energy, and this is due to the motion of particles. Just like we sort of talked about with temperature, if you add heat, you would raise the temperature because the motion of the particles increases, so that kinetic energy increases. So that's what we consider average heat, is temperature. We don't measure cold, just to let you know, we do measure the lack of heat. Okay. So when it comes to measuring energy, there's two major types of units that we use. The first is referred to as a joule. This is a capital J. This is the SI unit for energy, but it's kind of really tiny. So we often use the term kilojoule. Okay. Next we have calorie. Now this is abbreviated CAL, and you might be familiar with this, or maybe think you do, because a calorie is defined as the amount of energy to raise 1 gram of liquid water by 1 degree Celsius. Well, here's the thing. The food calories that you're probably familiar with are actually a kilocalorie. And a lot of times what we do is we just abbreviate this with a big C instead of little CAL. So that's a big C. That's actually 1,000 calories. So it would be defined as the amount of energy needed to raise 1,000 grams of liquid water by 1 degree. So 1 calorie is equal to 4.184 joules. That is an exact number, so you don't need to worry about that when you're calculating things. Okay, similar to like that calorie, how we define it, is another term called specific heat. And what this is it's basically a similar type of definition for other substances. So this is the physical property of a substance. It varies for different substances, and it varies for different states of matter for different substances. So specific heat is defined as the amount of energy needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. And again, the state of matter has to be correct. Okay, so if we can put it in terms like that, we can put it into some units and give it an equation. So let's go for it. So if we say that specific heat is defined as SH, we could say that that would be joules over grams times degree Celsius. Or sometimes you see it like this, which is like a dot in between. And as a matter of fact, sometimes we see it in text, and it's written sort of strangely because it's like J over G times degrees Celsius. That is meant to be like all of that's on the bottom of that fraction. Sometimes you might even see this is written in calories. So calories over grams per degree Celsius. If we were to put that into an equation though, specific heat will be equal to heat, because remember heat is energy, and that's where we get joules from, divided by mass times change in temperature. So here's what change in temperature means. Remember, change in means that you're taking the final temperature and you're subtracting the initial temperature. So that's what that delta T means. We can rearrange this equation just to make it a little bit easier so that heat is equal to specific heat times mass times change in temperature. So we probably need to try an example. So here's an example. How much energy is needed, or is used, to heat 10 grams of aluminum from 20 degrees Celsius to 60 degrees Celsius? And it gives you the specific heat of aluminum is 0.897 joules over grams times degrees Celsius. Well, we're looking for heat. So this is our unknown, right? And so we need to set up our equation. I just transfer that over from the previous page. And we just start plugging in numbers. So we know what our specific heat is. We can leave that here. We know we have 10 grams of aluminum. We got that right here. But we do have to figure out what the change in temperature. So we have to go with the final minus the initial. So the final temperature is 60 degrees Celsius. And the initial temperature is 20. And that's where this 40 comes from right there. So check yourself. Notice that I've shown where grams cancel and where degrees Celsius cancel. So our unit should be joules. Plug those numbers in and you should get this as an answer. But we need to report in sig figs, and we only have 3 of them because of the specific heat. And so incorrect number of sig figs, that would be 359 joules. Hope that's helpful. See you on the next one.